Strategy Management Series. Video number 110 Strategy Formulation. Step 7 Strategy Evaluation. Step-by-step guide to simultaneous moves games. Welcome back to the Ready MBA series on strategy management. In our previous sessions, we delved into strategy evaluation, the crucial seventh step of the strategy formulation process. This stage entails scrutinizing potential strategies for their impact, benefits, costs, and resource requirements. We also introduced the concept of game theory, a technique for predicting competitors' moves in a competitive situation, demonstrating how it can be leveraged by the planning team to refine their strategic analysis. One of the primary benefits of game theory is its ability to help decision-makers anticipate the potential outcomes of different strategies and understand the ripple effects of their choices. This is especially valuable during strategy formulation and evaluation, as it allows planners to simulate various scenarios and assess the best course of action. Game theory distinguishes between two types of games: sequential moves games and simultaneous moves games. Sequential moves games involve players taking turns, with each move visible to subsequent players. This allows each player to base their decision on the actions taken by previous players, providing an opportunity to adjust their strategy accordingly. Simultaneous moves games, on the other hand, involve players making decisions without knowing the moves of others. These games often require different analytical approaches due to the uncertainty of competitors' actions. In our last video, we covered some of the details of simultaneous moves games, explaining some key concepts such as payoff matrix, dominant and dominated strategies, equilibrium, and identification of the best strategy. In this video, we will present a step-by-step guide explaining how the planning team can identify and analyze simultaneous moves games. Simultaneous moves game theory analysis is a method used to evaluate strategic decisions where players make their moves simultaneously without knowledge of each other's actions. The following is a detailed step-by-step guide for conducting a simultaneous moves game theory analysis, illustrating each step with an example. Step 1. Identify the game and the players. Identify the context of the game and the players involved. Determine what the players are trying to achieve and the choices they have. For example, consider a pricing strategy game where two companies, Company A and Company B, must set prices for a similar product in a competitive market. Each company can set a high or low price, impacting their market share and profitability. Step 2. Define the strategies for each player. Identify the possible strategies each player can choose. In the pricing example, each company has two strategies: set a high price or set a low price. List these strategies for each player. Step 3. Create a payoff matrix. Create a payoff matrix to represent the game and analyze the strategies. The rows represent the strategies of one player, e.g., Company A, and the columns represent the strategies of the other player, e.g., Company B. The number of rows will be equal to the number of strategies by Company A, and the number of columns equal the number of strategies by Company B. For the pricing example, we represent it using a 2x2 matrix where Company A's two choices are listed in the rows and Company B's two choices are in the columns. Each cell in the matrix displays the payoff for Company A first, then the payoff for Company B, corresponding to the strategic moves made by both players at that intersection. Step 4. Assign and estimate payoffs. Estimate the payoffs associated with each combination of strategies. To estimate payoffs, consider the potential revenue, costs, market share, or strategic benefits resulting from each outcome. The planning team may need to develop business models and financial projections to estimate the payoffs for each combination of strategic moves. In our pricing example, payoffs could be the expected profits for each company, depending on the pricing strategies they choose. To estimate these payoffs, consider factors such as market demand, cost structures, competitive dynamics, and price elasticity. If both companies choose a high price, both Company A and Company B will get 8 million in profits. If Company A sets a low price while Company B sets a high price, Company A earns a profit of 5 million, while Company B earns a profit of 15 million. Conversely, if Company A sets a high price while Company B sets a low price, Company A earns a profit of 15 million, while Company B earns a profit of 5 million. If both companies set low prices, they each earn a profit of 7 million. Fill in the matrix with the corresponding payoffs. The example payoff matrix would look like this. Step 5. Assess the payoff matrix for dominant strategies. Determine if there are dominant strategies for any player. A dominant strategy consistently provides a better payoff than other strategies, regardless of the opponent's moves. To find a dominant strategy for a player, compare the payoffs for each strategy against all other strategies. Now that we have our payoff table set up, let's look for any dominant strategies. First, we focus on Company A. We compare the rows of the matrix, checking A's payoffs in one row against the other rows. The aim is to see if there's a row where all of A's payoffs are greater than the payoffs in the corresponding cells of other rows. Whenever we identify such a row, it then represents Company A's dominant strategy. In this example, the row for A's strategic move of high prices shows systematically higher values than A's payoffs values for low prices. When comparing the corresponding cells in the two rows, we note that 15 is bigger than 7, and 8 is bigger than 5. High prices then represent Company A's dominant strategy as it offers the best outcomes for all combinations of strategic moves between the two companies. Now, let's look at Company B. We'll do the same comparison, but this time, we'll focus on all the columns. We'll compare the payoff values in corresponding cells across different columns. When we compare the values in the two columns, we see that 15 is greater than 7, and 8 is greater than 5. Therefore, setting high prices is Company B's dominant strategy as it yields the best outcomes for all combinations of strategic moves between the two companies. Step 6. Assess the payoff matrix for dominated strategies. Dominated strategies are those whose payoffs are lesser than the payoffs for all of the other strategies. This means that they should not be adopted as players will be worse off compared to the other strategic alternatives. Identifying dominated strategies is helpful especially in more complex games because they can be removed from the payoff matrix, making it smaller and simpler to be analyzed. The process is similar to that for dominant strategies. Compare payoffs across strategies, row by row, or column by column. The dominated strategy will have the lowest payoffs when compared to the corresponding cells in the other rows, or in the other columns. Since we have a small and simpler payoff matrix in our pricing decision example, it is not necessary to search for dominated strategies. However, this exercise can be helpful in larger games, where the elimination of dominated strategies can reduce the size and complexity of the payoff matrix. Step 7. Identify the best strategy based on dominant strategies or equilibrium. If both players have dominant strategies, identify the cell where they intersect in the payoff matrix. This cell represents the outcome of the game when players follow their dominant strategies. In the example, both companies have a dominant strategy of choosing high prices, leading to a payoff of 8 million for each. If no dominant strategies exist, assess the best strategy based on each player's best response to the other's strategy. This process identifies the Nash equilibrium, where each player's strategy is the best response to the other's strategy. We will discuss Nash equilibrium in more detail in upcoming episodes. Step 8. Evaluate strategic implications. With the optimal strategy identified, evaluate the broader strategic implications for the players. Consider how this strategy aligns with their overall goals and whether there are any risks or trade-offs involved. This evaluation helps ensure that the chosen strategy is robust and sustainable. Also consider potential variations or uncertainties that might affect the strategy's effectiveness. Test the strategy against different scenarios to ensure its resilience in the face of changing conditions or unexpected moves by competitors. Step 9. Implement and monitor. Once the optimal strategy is identified, it can be implemented in practice. Continuous monitoring is crucial to ensure that the strategy remains effective as conditions change. This monitoring allows players to adjust their strategies as needed based on new information or evolving market dynamics. By following this step-by-step guide, you can conduct a comprehensive simultaneous moves game analysis, providing valuable insights for strategic decision-making and allowing for effective planning in competitive environments. And this concludes our episode about the step-by-step guide to analyze games with simultaneous moves and to identify its optimal strategy. Please join us in our next episode where we will continue our discussion about game theory. Until then, keep strategizing. See you soon.